Great to see so many of you here, and thank you for braving the rain to get here. Hopefully we've got a few people online who can, with a bit of luck, hear us. Somebody give us a thumbs up, or don't think we'll be able to hear you. Yeah, we've got a thumbs up. Great, thank you very much. So I'm Chris Field. I'm the Secretary of the Railway Division South East. A little bit of housekeeping to begin with then. We're not expecting any fire alarms, and if we do have a fire, then please follow Dominic. Yeah. And he will lead us to safety. Dominic's also our first aider in the event that we need that. The presentation is being recorded, so you'll all be on video. If you're not happy with that, please let us know. We'll hide you away somewhere. And that will be available later on the IMechE website, through the IMechE website. We will, of course, have an opportunity for questions and answers at the end of the presentation. And today's topic is, of course, re-signalling the underground, specifically the 4 subsurface lines: the Circle, District, Hammersmith and City and Metropolitan lines. Some of the oldest parts of the underground, with some complex flat junctions, interfaces to other signalling systems, both internal and external to London Underground. Understand it carries 40% is 40% of the underground network and carries 1.3 million passengers every day. And of course, it's not just re-signalling, it's also implementing ATO, automatic train operation, and addressing all the associated challenges with that and integration. The overall intent of the project is, of course, to increase the throughput and increase capacity for the underground. So our speakers that I'd like to welcome today, we have Chris Hobden, who is the 4LM Project Director. He's a chartered civil engineer. He's been 14 years on the project in one way or other, right from the beginning of the introduction of the NUS stock trains. So we welcome him. And Sam Etchell, who is a chartered mechanical engineer. He is the head of engineering for this and all the major programs on London Underground. And we welcome him as well. So please join me in welcoming them to talk about re-signalling.
Thank you very much for the introduction. So I need to stay tethered somewhat closer to the microphone so everyone can hear. We've got quite a lot of material to go through, so we're going to canter through it at speed, and we'll try and get some time for questions at the end. I'm also going to cover a little bit about the rolling stock rollout as well, because we effectively re-signalled the railway using legacy signalling to get the rolling stock out, and now we're re-signalling it with ATC to get the increased capacity. So what is 4LM? 4LM is the Circle, District, Hammersmith, City and Metropolitan lines. The pie chart on the left shows the proportion of the underground passengers compared to other modes of transport. It's pre-COVID, and I suspect cycling and walking has increased now a little bit. There's the picture of the transport strategy at the bottom, because this programme does get a specific reference in there, because it's effectively sweating the assets and getting more capacity out of the existing system. As was just described, it was carrying 1.3 passengers per day pre-COVID. I think we're above COVID levels now at weekends. We're at COVID levels on the old Tuesdays, Wednesdays and Thursdays, but not so good on Mondays and Fridays, which you're probably all very familiar with. Programme has an estimated 5.5 billion outturn cost. So if we continue on, and the objective, those 4 lines cover 40% of the network, and we're going to increase that capacity by 33%. So you can imagine the business case for that is significant. Even with COVID, we still need to complete the scheme, because we have to replace the life expired assets. Some of the signalling is 70, 80 years old. It was Boris Johnson that described Edgware Road as being held together by sellotape and bubble gum. I'm not sure he'd actually been there, but we won't go into that. Top map is the one you'll recognise. The one in the middle, I always think is worth showing, because it shows the true extent of the geography on the Met out to Amersham, and the other end district out to Upminster. The geography is significant. Bottom left is the cutaway of what the 4 lines are. divided into migration areas, which I will cover. So in terms of some stats around it, that's 310 kilometres of track on those 4 lines. We had 4 depots. We're now down to 3. We took Hammersmith out. That's now ATC enabled stabling. We had 178 trains of the legacy C, A and D stock. We now have 192 S stock split between the S8s and the S7s. We are currently running around 28 TPH in the core. To get the capacity, we've got the longer trains, which have a little bit more capacity in the trains, but predominantly by putting more throughput through, we get the increased capacity. And the intention is to get up to 32 TPH. We've done some minor TPH increases to date. Most of that comes as we complete. 46 signaling equipment rooms. These are, in my language, more like data centers. They're robust structures with dual power supplies, security, environmental controls, and in difficult locations. And I'll show you some pictures in a moment. On the network, there's 113 stations on those 4 lines. We now have 1 service control center down at Hammersmith. Along with the S stock, we've got 33 engineering vehicles that are not quite as new. Some of those are very old and a real challenge for fitment of kit. CRMS, cable route management. So TfL have had the responsibility of building the signaling equipment rooms and providing the primary cable route management. We anticipated building 150 kilometres. We've actually built 235 by the time we've been round both sides of the, well, not both sides of the track in all locations, but some level of redundancy, and weaved our way through some rather tortuous locations. The values at the bottom are at the point of awarding the contract to Thales for the resignaling. The award value was 760 million, and the 800 million on the right-hand side is the value of the work that TfL had to deliver. And I put that up to demonstrate that both parties really need to work together to deliver this. And that's something that is a lesson loud and clear for me through this type of work. So Sam's going to come on to the technology in a bit more detail. But if you take the 4 lines, we are building on the baseline signaling software that was used on the Jubilee line, CellTrak IS, then on the Northern line. And the rollout strategy was to go around the core. So you're looking at Hammersmith, or the Circle line, effectively, Hammersmith round on the Teacup service to Edgware Road, the core, and then out to Upminster on the east end of the district line. So the theory was we can lift what we've taken on the Northern line, adapt it, and use that on that section of railway. It also happens to be the most complex bit of railway with 4 flat junctions and all the interoperable issues of engineering vehicles, etc., needing to use it. That's the theory. We knew there was delta functions. There are some 185 delta functions, so that's not a small number. Then if you come up towards Nice, I'm trying not to point at the slides because those on Teams might not be able to see that. But if you go up the Metropolitan line then to what's labelled on there as SMA 8 or B, the green B, you are heading to Neasden, and that section has what we call underlay. That's where we are taking out the old signalling interlocking, replacing it with a CBTC VCC, Vehicle Control Centre. And CBTC, if anyone, sorry, I've launched straight into abbreviations, communications-based train control. We will take out the existing interlocking, put in a VCC, and then use that to control colour aspects, because on that section of the line, we have the Chiltern line running over the London Underground infrastructure. So the Chiltern drivers will drive to new colour aspect signals. The S-stock will be automatically controlled by the VCC. So that's a different version on top of the core. Then as you come and there's variants of that, because out to Amersham, you've got the Chiltern line, whereas out to Uxbridge, you've got the Piccadilly line. They are alien trains that are not fitted with VOBCs, vehicle onboard computers. So a different variant, more delta functionality required on that branch. Initially, we were coming all the way down to Wimbledon and Richmond, and we were going to install there what we called overlay. We're not carpet fitters. Overlay is where the existing interlocking remains, and we take the feed from that to control the S-Dock trains. We came away from that for a number of reasons: a significant level of technical risk, and the fact that we didn't need to do it because it added nothing to the timetable benefits that we were trying to deliver. And in fact, it would make reliability worse because we'd have two systems, one overlaying the other, and some complex management interfaces. Who responds to the fault? How do we know what the fault is? Have we got blue lights from Network Rail and London Underground trying to fix a fault? So it was a decision taken. I tried 3 times getting it to the board, and it was only during COVID, when we had to save money, that it was agreed that we wouldn't do it. And also a change in transport commissioner that didn't live on the Wimbledon branch. That might have been a factor, I don't know. So complexity. The map is the broken down 4 lines. You can probably orientate yourself. You can see the Jubilee line, the Piccadilly line. You can see the East London section, and this does still include the South West trains, etc. So the complex layouts are in orange, and you can see the flat junctions around at Praed Street, at Edgware Road, Baker Street, Minories Junction, Earls Court, huge complex junctions. And then the unique interfaces are the blue sections. Neasden, let's pick on that. Neasden has got the interface with the Jubilee line, which is a Thales CBTC system, or TBTC, sorry, train-based control. So we've got the interface with that, and also with the depot PMI system. I can't actually remember what PMI stands for now, but I'll let Sam try and remember that by the time he comes on. We've got basically trains on the same section of track that are effectively going to be controlled by 3 systems. So there's hierarchy and all sorts of difficult questions to resolve there. So a lot of very unique interfaces. It's often been described as the world's largest and most complex resignaling program. I'm struggling to find any real competitors to it, although I have had an explanation of the East Coast, and I think that's got some complications of its own to compare with. So the rollout strategy, as I say, was to do the core. The green there is what we've done. So we have communications-based train control running on the whole of the Circle line, the whole of the Hammersmith and City, and the east end of the District line out to Upminster. The last section out to Upminster was commissioned in March of this year. Next is we move up the Metropolitan line out towards Neasden and Harrow. We are trying to do the sections. We've put SMAs 10 and 12 shown bottom left. When we descoped, we put those pieces back in because there is no future signalling plans for that area. The assets will need to be replaced, and we can put vanilla CBTC on those sections without going into overlay. So those smaller SMA 10 and 12 came back in after we originally took them out. It was all part of the same discussion, but we tried to separate the commercial aspects of it out. I think that probably covers that. I talk about collaboration. This has to run all the way through. Thales are co-located with us in the offices. The only way you will walk around the floor and spot who's different is the color of the cable going to the back of the computer. And half the staff that work for Thales probably used to work for TfL, and half the TfL staff probably used to work for Thales at some point. So at the working level, the relationship, I don't think I could ever ask for better. The contract is structured to try and embrace that collaborative behavior. It's a target price with gain share and pain share. Sadly, we are very much in the pain share section at the moment, but it still drives both parties to reduce cost, and you reduce cost by working together. So the basics of it are there. Doesn't mean that life today is all a bed of roses. There are obviously challenges because we're late and it's costing more than was anticipated. If you ask me why it's costing more and it's late, the sheer complexity, I don't believe, was ever properly understood at the beginning. But the formal contract is a very key player in driving our behaviours. I talked about signalling equipment rooms being mini data centres. They are all complete, but some of the locations there, top left is on the top of a difficult embankment down at Ealing Common. The one here that appears to be underground is under a Sainsbury's car park around Lily Bridge, around that sort of area. This one at Ealing Common, the planners wanted to make sure that the light could still get into those nice little windows for the station. So we had to sink the whole thing into the ground, which I still worry is a lovely storm sump if we get some very heavy rain. But there are systems to cope with that. Down at Turner and Green, we chose to use the arches and then discovered that the embankment that was filling the arch was supporting the Piccadilly line, and we had to employ tunnelling techniques to create the space to build the room. So there is not 46 nice greenfield sites to build signalling equipment rooms in London. I'd almost ask for a show of hands as of what we think the cost of a signalling equipment room is, but I won't. I'll bear you the guessing. Between £2 and £3 million for a box that's probably about 25 metres by 15. Very expensive locations and significant well, not technology as such, but requirements that had to be met. Cable route, we're all familiar with the fence along the side of the railway. That's the easy stuff, relatively. Get into platform inverts or into the tunnels. Obviously, the existing signalling needs to be maintained whilst we're doing all of this. So from a maintainer's point of view, we're putting it up at height. They don't want it at height, but there is no choice. So we've gone through difficult conversations. We've had to take operations and maintenance with us all the way through this journey. Lots of over-track crossings, under-track crossings. So again, CRMS, a simple asset, but actually quite difficult to build and very time consuming. And you have to have your system design done to know your power and your system requirements, your cable capacity requirements before you build it. But we've got to get building before that's available. So all sorts of interesting decision making needed. Once we've done the signalling equipment rooms and the cable route, Thales come along with the black boxes and the licorice. What is that? So there's Wi-Fi access points. There is cut-in to the point motors, etc., etc. Thales have undertaken a lot of that all of that installation themselves. We've helped them out with cable pull. I don't think it's an embarrassment to say, I used to work for Westinghouse at some point. Signalling contractors are not great at managing civil subcontractors. So where we could, we've tried to help out there. And tier 2 contractors tend to have a better relationship with TfL because they want to come back for more work, whereas they see Thales as a one-off opportunity. So there is a number of good reasons why we've taken some work away from Thales. Hammersmith Service Control. So the 14 migration areas move into Hammersmith. On the 5th of April 2018, Hammersmith's a purpose-built structure. The management of the subsurface railway moved into there on the 5th of May. And then as each migration area switches across to CBTC, that desk livens up in Hammersmith. The intention has been to have service control operators that can move from one desk to another. The complexity is seriously challenging that at this moment in time. The knowledge that each area requires a service control member of staff to have is significant. But it's definitely a functioning room now. Those pictures go back to the beginning. If you go down there now, there's a nice TV set up with a cupboard full of sweets and all sorts of things for you to buy. The S-Dock, that was delivered in November 26. That's all complete. I don't know why there's automatic moving forward on that. You must all be familiar with those trains, walk through, air conditioning. All the feedback I've ever had from customers has been very, very positive. And I was going to say, I think it's a very reliable train, but with Graham in the room, I'm not sure I should make any comment, but from my perception, it's been an excellent choice. The signalling kit, it was a train that was designed initially to have a Westinghouse system in, then a Bombardier signalling system, and we've now fitted a Thales signalling system. I don't know why I've got all of that going on, sorry. So with the installation of that kit, we took the trains back to Derby. They were stripped down and fitted with the kit, but that's all been done. And the next slide, which you've just had sight of, that's the ATC train fitment. It's a 23-day cycle. Diesel hauled the trains up to Derby. Very intrusive strip down of the train to put kit on the motors, the brakes, the axles, etc., etc. 23-day. And bearing in mind, I talked about collaboration. This had to be done post the termination of the Bombardier contract as a three-way agreement between Thales, Bombardier and TfL. All sorts of opportunity, but actually went very, very well, and was delivered to time and without any reliability impact. I always envisaged that level of intrusion would have a consequence on reliability, but it never did. So that was very promising. EV fitment, very different, very old rolling stock. We decided to do that entirely in-house. We've employed fine wire, I'll forgive the phrase, wireman skills to do that. That's been done at our own depot at Ruislip. And again, it's worked. The decision to do it differently was appropriate, and a sort of 20-day cycle, largely complete. We've just got, I think it's the tamper, a new Matisse tamper or two to fit. Depots. We bought a longer train. Lesson for me is don't try and refurbish a Victorian depot. Very difficult. You can lose your shirt on that as easily as you can on a CBTC project. We did refurbish both Upminster, Neasden and Ealing Common. We've had to extend the sheds. As soon as we got there, there was a huge crack in the wall, which funnily enough, no one had seen before, where the whole gable end was falling off. So all sorts of untold extra work to do. And you can see the scale of the work inside the shed to move roads around. New train, new systems requiring completely different maintenance regimes, modern health and safety equipment to lift things, move things, doors around. So gangways that go above the train to get to the HVAC, etc., etc. So the depot works are largely complete for the S-Stock rollout. We are still working at Neasden for what's called the heavy overhaul. The trains, when they get to the midlife, require a heavy overhaul. So that's gangways, HVAC and bogies. And that facility is being built now. I would say just in time for the heavy overhaul. We're running a bit late, is the truth. So we are running on some level of concession, but there is still depot works going on the project. Just going to do a time check. I need to move on. That's perfect timing, actually. Hand over to Sam. I come back at the end.
Yes. Thank you, Chris. So I've got 15 minutes or so. I'm going to go through a bit of the technical stuff, the system architecture. I'll talk about some of the system integration challenges we've had trying to make this work in London. Talk about how we grew reliability before we went into passenger service. And I think finally, quite appropriate to be in this building, I'm going to talk about how we assure and sort of do the back office stuff to bring a safety critical signalling system into use and convince ourselves it's good to go. So system overview that the signalling is on 4LM. It's an automatic train supervision system. So it's pretty much hands off for service control and signalers until something either goes wrong or they want to make some manual interventions, close a platform, reroute some trains for disruption reasons. But otherwise, load a timetable in, overnight it gets loaded up, and then trains just tell the driver they're ready to go, and the driver presses start buttons and off it goes. And it just regulates itself all through the day. And trains know where they're going, and automatic train supervision kicks in. So on a good day, if you visit Hammersmith Control Centre, it's quiet. No one's doing a thing really. They're just in supervising the computer mode. As automatic train protection, that's the SIL 4 high safety level integrity software that protects the train. So that's making sure the trains don't overspeed, don't drive into anything they shouldn't, and protects against collisions. And then there's the automatic train operation. So these trains can be driven manually, or they can be driven in automatic, which is probably 95% of the time they're driven. Train operator presses the start buttons, the system drives station A to B. We're going to get there. We're not there yet, but our intent to deliver that 33% capacity uplift is we need to be running 32 trains an hour in our peak services. I think we're currently at 20, 28, 29. So doesn't sound a lot, an extra 3 trains, but it actually is a huge amount of effort and work to do to optimize the signaling layouts and the software to get to 32. So that's still end state for us. I always like that picture, kind of shows the same platform Baker Street back in the steam days, and that's it with an automatic train CBT signaled in the same platform. So the infrastructure has not changed so much, but the technology in the tunnels and on the trains is massively different. It's a bit of a busy slide. I borrowed it from Thales, our signalling supplier, but I'll quickly go through how the architecture is. I'll start down at the train. So the train drives along. It uses a Wi-Fi system to talk to the wayside. So that's a pretty standard 2.4 gigahertz Wi-Fi system. There's access points it's a line of sight system. So the access points are deployed on the wayside wherever they're needed. Kind of survey the railway, work out when the signal starts to drop, put in another access point. Round tight curves, you'll find more access points. On plain straight track, the signal can propagate a long way, and they're every 200 meters. So the train front and back talk via standard Wi-Fi, not quite standard, high security, etc., etc. The train knows where it is. It's got tag readers on it, and every 25 meters, we've fitted tags. So every time it reads a tag, it knows absolutely where it is. So, and there's some axle counters on the track, which obviously count the axles from a train in and out. That's not really used in primary mode. That's more if all those systems on the train fails, axle counters are used as a secondary train detection system, and it kind of counts a train and it won't let anything else into that past the axle counter until it's counted the train back out the next axle counter. So they're only really used for degraded mode to allow us to continue running some kind of service if the whole comms system falls over or a train has a problem. That leads us into the signaling equipment rooms. There's what, 50 odd of them across that whole network. It's a big data center, as Chris says, with a big I/O box in it. So signaling equipment room's main job is to interface to the wayside equipment to get the points, drive the points on the ground, drive the point motors, turn signals on and off, and monitor the state of the axle counters. So it's generally a data center to gather the data from the wayside about what's going on, and also to change the configuration of the wayside equipment. All of that feeds up into Hammersmith. All those 14 sections that Chris showed you has a VCC, a vehicle control center. That is the absolute brains of the signaling system. It does all the sort of what a traditional interlocking would do, and works out where all the trains are, gives movement authority to trains, and determines if it's safe for a train to proceed or not. So that's really the sort of SIL4 brains of the system. And then all of that feeds up into the SMC, which is that picture there, which I didn't talk about. That's the graphical user interface an operator uses. Everything talks over a massive data communication network. So I think it's probably one of the biggest networks in London that we've installed to make all of this kit talk to each other over such a huge geographic network. A lot of fiber optic cables, which I learned just recently is really bad for our carbon footprint. So 4LN is actually a bigger user of carbon than the Jubilee and Northern upgrade that came 10, 15 years ago, because we put lots of fiber optic cables in. We built a lot of concrete bases to put all these masts for all these antennas. Actually, it's not a very green solution, which is pretty important in this day and age, and quite fascinating as TfL go on this journey to become greener. Some of the engineering systems we're putting in are not necessarily aligned to that. So system integration, I've got 2 slides. I'm going to talk about a little train journey from platform A to platform B and how it works. Most people get on a train, it sets off, usually gets to the next station pretty seamlessly, and everyone gets off again, and everyone thinks that was great. But the amount of technology and systems working together to deliver that journey is pretty impressive. So I'm just going to try and talk through them in a few minutes. So it all starts with a CBT command. So up at Hammersmith, that decides where every single train on that entire network can go, whether it can proceed or not, and how far it can proceed. So it then issues a command out over the network, which can have to travel thousands, hundreds of, not hundreds, that's a bit extreme, lots of miles to get to the train it's necessary to get to. So once it gets to CBTC command, it goes over this DCS network that we put in. I mentioned it's Wi-Fi, but it's actually all encrypted. All the trains have a VPN, virtual private network, dialed up to the control center. It's a bit like the technology you may use on your corporate laptops when you connect VPN to get into your work networks from remote locations. When it goes wrong, which it sometimes does, it's been a huge challenge for us as maintainers and engineers in TfL to diagnose that kind of technology. And we don't have a C&D IT specialist department in the signaling teams that we can just phone and work out why our VPNs are not working. So we've had an awful lot of early problems getting that cybersecurity element of the system robust and reliable. But once it does make its way through all the network switches, all the routers, gets encrypted, decrypted, gets sent over the air to the train takes it, it feeds it into that onboard train computer thing there with all the wires in the bottom left as you're all looking. And that sets a target point to the train. And that's pretty much says to the train, you are safe to drive the next 500 meters, 1,000 meters, depending what's in front of it. The thing that generated the command, the VCC, knows where every other train is, so it can say to that train, you are now safe to proceed to this point, and you can drive at this speed. So then the train goes. After all that's been worked out, it tracks its way through its journey via some sensors. So we've got some tachometers, and we've got some tag readers, and we've got some accelerometers on the train, and all three of those kind of work together to determine what the train is doing, how far it's traveled, and at what speed it's going. All of that is fed back to the top system via the Wi-Fi network, who supervises that train. So you're going too fast, etc., and will immediately stop it if need be. A big problem we've had here is the tachometer, to know the distance traveled, relies on wheel revolutions, which is a function of wheel size. This system has no like automatic wheel calibration on it. So every time our maintainers do some wheel turning to reprofile the wheels, the system thinks the wheels were 700 and whatever millimeters, and suddenly they're different. So its distance tracking gets all wrong, and the train just keeps stopping as a result. So getting our maintainers to understand how this system works, so that when they do traditional activities such as wheel turning, they can feed that information back into the CBC system has been a challenge for us. Then we go into, we still haven't really got to our station yet, but we have this driver's display, which is a big software display now, which tells the driver it's pretty much a train operator's only window into what the signaling system is thinking. So we put a driver on the front of the train, they press the buttons, and then we kind of tell them how far they've got to go till their next obstacle, and at what speed the train should be driving. The driver's role there is really, well, they don't have to supervise it because it's a high integrity software system that will always work, but they do an element of human supervision, which is a natural thing for someone who's kind of in charge of the train, and this display allows it. So then we sort of get to the next station, and we have to brake the train, which is arguably the hardest bit for the CBC system. The system has to stop the train sort of within the window about so big at some platforms, plus or minus 30 centimeters, 40 centimeters. It has to stop a train. That train will be in all sorts of weather conditions. The railhead conditions will be whatever they'll be on the day. And it has a variable number of people on there, depending on the time of the day. And a bit like driving your car, how you brake in those conditions is different. So the control loop on the train has to kind of know about all of that. It has to know how heavy the train is. It has to know about the adhesion conditions, and it has to try and stop. And we use a combination on these trains of dynamic brake and friction brake, so the electric brake. And we've had a huge amount of problem that when the dynamic brake gives up, because at about 13 kilometers an hour, it has no more energy to sort of dynamic brake, and the brake box come onto the wheel and do that last little bit of the stop. It provides this big jolt, and the train suddenly slows down. The controller thinks the train's slowing down, so it backs the brakes off, the brakes come off, the train speeds up, and you get into this little, well, quite big control loop oscillation right at the stop point, and trying to stop on the money was a real challenge. So we had a huge amount of tuning to do with the rolling stock manufacturer to adjust how their train brakes effectively, and the control loop people with Talis to do it. So adhesion, I mentioned, something we do on TfL and especially on 4LM, which is a bit unique to us, is we proactively manage the adhesion on the railway. So we have a system called ACAT, which one of our brakes engineers kind of pioneered back in the day, I think. And what that basically does is it takes in all sorts of environmental information into its algorithms, weather data, all sorts, and it makes a prediction that this part of the 4LM network at 2 o'clock this afternoon is going to suffer poor adhesion. Maybe a storm's coming through or the wind's picking up, who knows, or it's that time of year. And what it'll do is up at the control center, it will alert the maintainers and the operators that poor adhesion's on its way. So what that means they can do is dynamically adjust the braking and acceleration rates this train automatically uses. So when it's poor adhesion, we drop the brake rate, drop the acceleration rate, and try and minimize wheel spin on acceleration, or just sliding away when we come to brake, same as you would defensively drive a car in poor adhesion. Vanilla out the box, the CBC system has no idea about the condition, so it can't defensively drive. It just does the same thing every single station stop. And if there's poor adhesion, tough, you have to overrun or have a reliability problem. What we can do is proactively adjust brake and acceleration rate to mitigate that risk. And yes, passengers have a slightly longer runtime because everything's going a little slower, but ultimately that's quicker than having trains overshoot platforms or come up in an emergency brake because of wheel spin. So, and then the system does the same when it says like the weather event has ended, you can go back to normal default driving. So it's something we use that not many other metros or anything around the world tend to use. And then we have our accurate positioning. Like I said, we have to stop 30 centimeters or so, plus or minus, because it's often this signaling system decides if it's safe to open the doors or not. So it absolutely needs to know where it is, because what you don't want to do is have the train overshot or undershot and the signaling system thinks the train's in the right place, opens all the doors, and then passengers fall out into the barriers or even worse onto the track. So we have to make sure that the computer that enables the doors to open knows it's absolutely in the right spot, and then it can safely open the doors. So the CBC system takes care of determining that it's absolutely in the right position. It knows which side the platform's on, and then it will enable the doors and allow a train operator to open the doors. Obviously, there's a bit of a secondary check now because we do still have a train operator that if the computer has got it wrong, the train operator can go, oh no, I'm not going to do that because I can visibly see I'm nowhere near that green marker there, which is the driver's indicator that the train is in the right place. So all of that has to work together to just go from one station to another, and we have had an enormous amount of tuning to do to get all of that working at every platform where we've got curves, gradients, uphills, downhills, some platforms busy, some platforms empty, and so on. Chris spoke a little bit about EVs, huge challenge for us and the signaling system. CBC systems really need to know how long a train is, and then they know where the back of the train is, so they can get the train behind as close as is safely possible to the back of the train. When you have an engineer's vehicle like we do, that could be anything from 18 meters to 132 meters, presents a real challenge for knowing how long that train is. So we've had to develop some, Talis have to develop some very clever software to try and dynamically work out how long the train is. And once it's worked it out, it can allow other trains closer together, because our intent on 4LM is to interrun our engineers' vehicles with our passenger stock, so they can go to work sites and other bits of the network in traffic hours. Traditionally, we have to do that in closed engineering hours, as we call it, which is closed to passenger service, but that's just not practical for a network like 4LM. So an enormous amount of thought and work has gone in. Bit on system reliability. How do we get there to the point we're confident to put the system into service? We do a thing called shadow mode. That's on the next slide, so I won't dwell on that. You may be one of those customers that wonders why we're always closing the network at weekends. What we're actually doing is we cut over the signaling system. It's all installed. We actually put it in active mode, close it to passengers, and we run 4 to 6 test trains all weekend, all night long, 24/7, up and down, doing what we call system tests. So that's proving the train is stopping accurately at every platform. It's proving the tags are all in the right place. It's proving the radio comms are reliable, using real world things. So we generally, for one of those sections Chris spoke about, we have anywhere between 4 and 6 weekend closures to do our required testing on site. We collect heaps of data, and then fix some things, fix the wayside, sort the software out, and eventually we build a reliability case that it's reliable. So we do that mainly via a thing called shadow mode. So before we cut over a system into real CBTC, all the equipment gets installed, it all gets powered up, all the radios, all the tags, and trains run in the legacy signaling world. But they're effectively, the CBT system is tracking them, monitoring them, and talking to them as though it was a real controlled signaling train. And we can weed out any reliability problems, any poor areas of radio coverage, any tags that perhaps a maintainer's covered in rail or knocked up or are installed incorrectly. So it's a thing called shadow mode running. So that, while the service is running every day in areas we've not commissioned, is actually well on the way to being signaling enabled. Testing. So what sort of testing do we do to bring the system in? First stage is a post-installation checkout. Once it's installed in those equipment rooms, that's really a check to make sure the wires run from A to B as per the design. It's a basic sort of signaling check that everything's wired right. Then we do local correspondence testing, which powers the kit up and makes sure box A can talk to box B over the network and that every line of communications in the design works. And we go into simulator and factory acceptance testing, which is mainly done in Canada, but that's about a 3-month process, give or take, where that is where the majority of V&V happens for the software and the system in the factory. We do a lot of bust-it testing with our operators. We do the system testing. And then in some areas, we go into what's called trial operations, where we run closed doors to passengers, but we actually use real operators and we run a real service in the background, but we just don't open it to passengers, and we get confidence that in a real operational scenario with real operators, real signalers, real drivers, not test ones, because on testing we use test train drivers, that it will all work and the operators are ready to take the system. They know how it works. And my last 2 slides, it's a bit difficult, but I just wanted to quickly walk through how we assure it. So this is SIL4 software, the highest safety integrity level you can get, as you'd expect. And we have to assure it. So we follow ROGS via our regulations, which calls for a level of independence. It calls for an independent, competent person. So we use an independent, competent person in our process. We use a system review panel, which is a bunch of a lot of independent experts from around different disciplines. System review panel, and we use an ISA, independent safety assessor, and we follow a standard TFL assurance process. What it ultimately comes down to is a safety case gets written for the signaling system, which brings in the design, the testing, evidence, the hazard management, all the good engineering desktop work that goes on to support the system. That all comes in a safety case. And then at the very end of it, there's a safety letter that gets issued to say from the supplier to TFL that the system is safe. You can go and put it into operational service. You can carry customers. And we have validated this system in accordance with safety critical software standards and things like Senelec, which you may have heard of. So we absolutely follow all of that. And then, yeah, we go into a bit of a process internally in TFL, where we go through our internal governance and system review panels to accept it. So we have this assurance process actually runs right the way through from design all the way to acceptance, and usually takes a year to 18 months to get through before we're ready to sign off into passenger service. And at that point, Chris, you've got 5 minutes.
So I'll quickly wrap up now. Is the project now handing it to the operator and what that means to the operator's business. So software development doesn't always go to plan. There's a number of hazards that come out of it, a number of issues that need to be addressed. The safety assurance process that you've just seen identifies those, calls them out, and TFL decides whether or not it can absorb those as an operational restriction or an information statement. What this shows is, since SMA 5, I think it is on the left-hand side, how we increased the number of operational restrictions to a level that it was unacceptable to the service control to cope with. It was too much for them to have to live with. We then put software builds in to bring that down. We've also taken some of the hazards and incorporated that into training so that it's now base training as opposed to what they were trained on, and therefore allowed to take the operational restriction out. The red boxes on there are things that we shouldn't have. These are safety operational restrictions. They are operational restrictions which, if compromised, could put the level of risk on the railway to an unsafe condition. Don't be alarmed by that. There's all sorts of the hazard analysis calculations around whether that's acceptable for us to proceed. But we try not to have safety operational restrictions. And we're currently sitting at around 90 operational restrictions, or no, sorry, we're currently sat up here, and the next build that's due to be going out imminently will reduce that down to a more acceptable level. So that's operational restrictions. This is the reliability of the railway since we first introduced CBTC. The blue line is the system. The brown line is the people and process on top of that. And you can see sometimes how that gap varies. It tends to open up at the go live commissioning, because when you go live, it's a complete change for what the staff are having to do. This is a big, it's a technology, but it's a big people change program. We measure our reliability on a daily basis. We report on it weekly up to directors. From a management point of view, that's really important because it keeps the project really tightly into the business and recognizing it's delivering something that's out there on the railway, not stuck in some ivory tower in Endeavour Square. So we measure our reliability, and funnily enough, we have to take that very seriously. In terms of operational readiness, so our operators and maintenance team, we have an embedded team in the programme. They are with us on the whole of the development, right the way from the operational concept through the development of the operational maintenance requirements and all the way down that cascade, so that we can take them on that journey, including our union consultation, including setting up the training. They're part of the testing to the point the operators will first be in the cab, actually with the ability to control the train is trial ops. And then we go into the service, the go live. And then once we've gone live, we still get issues found. We have to raise operational restrictions. So the relationship with our operators and maintainers is very close, and it has to be for all those reasons. In terms of what that meant, you've got a fairly small group of 150 people of service control that have to be staffed. And you've got a huge number of train operators that have to be familiar. They've got the route knowledge, but they've not got the system knowledge. So they have to be familiar. And we've done that on a line basis. So that now is all done. We've got union engagement. That can, as one would expect, this is a hot topic because it could be undermining the need for an operator in the cab. But this is a GOA2, so there will always be an operator in the cab. In terms of maintenance, very different approach, because we're asset-based and geographically based. So assets mean every system has its own maintenance team, and in the different geographies, they're all spread out. So you are suddenly down into lots of different groups of people, which have never been standardized before, but now have to be. You're also going from a, forgive my language, but from a hammer and grease gun series of maintenance to a laptop and swapping cards out. Very different mindset, very different training needed. Some people have not been able to make that journey. Others have absolutely relished it. But a real people change exercise, which if you talk to other clients around the world, which we have done because they've come to see what we've done, completely oblivious to that. They think they're buying a system, they'll plug it in, switch it on, it'll all be fine. And they realize actually our maintenance staff has gone up because of all the new staff that are needed to do the new systems. Building on that assurance that Sam talked about, there's the assurance countdown, which Sam largely described, going through the safety letter, the SRP submissions, system review panel, consent to operate, to get to a trial ops, and then a repeat of that to go live. We've got this one shows some work that we had to do parallel to that. We were strengthening the access points, but you can see down here the driver training, those staff briefings, and the whole operational readiness. All of that is running in parallel. And then we have a business logistics. Are we ready? This is effectively upward stakeholder management to our directors. We are going to be going live this weekend. You need to know that we're doing this. This has big reputational impact if it doesn't work on Monday morning, because whilst we have the 4 or 5 test weekends, we've probably only run about 400 or 500 train runs. We will have hit that by 10 o'clock on Monday morning. So if you're trying to find that reliability issue, we're unlikely to find it in our system test. We will find it in the subsequent weeks. So we do have to monitor that reliability and see what we're learning. That's it. Time-wise, how are we doing? Not bad. Open for questions.
Okay, questions. I know Malcolm's got a couple of questions online. Anything in the room, first of all, please?
So, what sort of lessons? Secondly, this last question. How do you know all the things you know?
I'm going to answer that one. I'll answer that one in reverse. So the technical director for Westinghouse was a guy called Phil Threlfall. And I know Phil from the time I worked with Westinghouse. He is now our IPAG representative. And he openly admits to me that he didn't know whether his system would work at the end of the day and has been very complimentary about what we've achieved. But we are also convinced that actually, yes, it would have ultimately worked. Absolutely convinced it would have worked.
I've got the system Victoria one, the one that was going. Based on what I know of that and this, I also agree. It wouldn't have been straightforward, but it's not. What work better? So this one hasn't worked badly. We'd probably be complete by now. So that's the thing. I don't think but better was really. There'd have probably been different problems, but we'd have had to put track circuits down and train detection panels with lots of problems. And the radios come with lots of problems. So I don't think it would be fair to multiply being better than this.
And with respect to East Coast, we've given, as Nigel will know, Nigel's in the room, we gave a very similar presentation to the East Coast team. And I think they were already very aware of the lessons that we've learnt from the conversations we had afterwards. Not all of them. Okay, maybe you should tell me. But the one thing I will always say about lessons learned, and I've seen this so much in TfL, particularly in the depot space, it's very easy to identify the lessons, and it's very easy for someone else to come along and pick it up and go, I've learned that lesson. Oh, it's in the contract, or we're not going to do that. If you've suffered the pain of it and then you go on to do it another time, you will have learned that lesson. But so often we think we've learned the lesson and we haven't. We've done it so often with depots, scoping the scope of works in depots, thinking we've got it right, and we've got it very, very wrong.
Yeah, they are actively talking to the net matches to talk about all lessons learned during fit device. Yes, so yeah.
Good, thank you. Another question?
Yeah. How was the transparency base system yeah, so
Sorry, just for the people who can't hear it online, that was a query about why using inductive radio-based rather than inductive loops and around the engineering trains.
well, I think that's the first one, seen as a more reliable, better product than running a wire in the track bed over such a huge network that's prone to maintenance problems and breaks and things like that. So I think, and our guest desire to evolve with the suppliers into a more modern system that has greater capacity, capability, scalability. The inductive loop is pretty limited in what it can do. This modern radio system can do more and is more cyber secure, but I think ultimately it was a reliability, a perception that the loop was going to be less reliable than the radio system. As it turned out that way, I guess the proof will be long term really, because we're going through that bathtub teething curve. Jubilee Northern has got the loop is steady state, so we kind of know what the reliability of it is. We've got to get this network to steady state, and then we can assess whether it was the right decision or not. There's pros and cons to it, that's for sure. And the second question, yes, half of the battery locos have 4 signalling systems on them. So the driver has to switch a big mechanical interlocking switch to power up the right one for the right line. And then, drive off and be in signalling protection on that line. So they have the 4LM system, the Jubilee and Northern system, the central line system, and the traditional Tripcock system, which is on all the bits of the network we haven't yet done CB2C on. So yes, they're getting very complicated and no space on them, and I don't think we could fit a 5th one.
We did consider a hybrid, but we descoped it because it was a technical challenge and risk that we couldn't afford time-wise.
Thank you. We might just take a question from Malcolm. Bear with me. I'll try and turn his volume up. Malcolm, go for it if you'd like to ask your question.
Hello, Chris. Hello, Sam. Thank you so
Hello,
much for
Malcolm.
an excellent presentation. The people in the room have been asking all the things on my mind, but one of the things that I struggle with is the long tail of software issues long after project handover, and maintainers always struggle to get the vendor to do any more software fixes. Is there any money in place for an account with Thales to make sure that this long tail can continue to get fixed?
Malcolm, lovely to hear you. That's a difficult one. We are really struggling with our scope at the moment, and is there any scope that we can take out? As I alluded to, software development doesn't go to plan. We have a huge number of unplanned builds. That's costing us a lot of time and money. We're adopting a minimum viable product, which has an element of risk on a network that is so complex, because this has to be reliable. A shutdown for 10 minutes at Baker Street has untold consequences right across the network. So we are looking very hard at some of the software change requests, and we're trying to minimize all the work that we're doing for 2 reasons: save time, save money, save complexity, because that in itself creates other issues. And you're right, there is a tail of issues that are likely to be there. We do have a mechanism in the contract that once we've achieved system, the last commissioning area of SMA 14, there is a period of time between that and full system functional completion where we have an entirely cost reimbursable component of the contract to fix the items that we want fixed. But that doesn't take us beyond the contract and what might need to be done then. So the real answer to your question, Malcolm, is that we are likely to then be in a framework contract. We currently have one for Jubilee and Northern, and there's many things those contracts can do. They can answer all the questions and resolve all of the issues if the funding is available, and that's the real challenge. These systems are not, as some people think, purchased, installed, switched on and left. They require constant upkeep. Microsoft licenses expire, they have to be replaced. New upgrades to Microsoft need to be done. All of those things are constantly coming along. So an investment in this type of system is an ongoing commitment, as you well know. So it is there, the facility is there to do it, Malcolm. It's the availability of funding, it's the challenge.
I understand. So my other question was whether there was any spare money to fit Sarah Siddons with the 1938 tube stock, seeing Graham sitting in the front row there. But I suspect the answer is no.
I think the answer to this point is your broadband's breaking up and I can't hear the question. No is the answer.
Thanks very much.
Thanks, Malcolm.
Thank you. Any more questions from the room?
Thanks for such a detailed presentation. Could you maybe just explain a little bit more about the key technical challenges you have where this is facing with network rails? So we haven't yet done that. That's our 9th section with the chilled trains for that. So far in our testing, we are in the system test phase up there, where the CPC system drives signal aspects, and the children trains drive to those signal aspects, and alien trains in the solution. So far, we haven't had any real technical challenges. Our biggest technical challenge is a sort of train prediction challenge between Malibu Control Center and the Thales system, getting those two systems to interface together. But that's not a huge challenge. That's just a bit of a mix up in the interface control documents that we've got. The two systems are not quite handshaking properly. That's been our biggest technical challenge. I'm not saying they won't come. And we've only, as Chris said, we've only run probably 10, 20 train paths through that area. And we're probably in a bit of a honeymoon period of that solution. So perhaps if you ask me that question again in a year, I'd be able to list them off. But the design's been quite challenging for the signal people to get their heads around how to deal with interoperability. And that's been 8 to 10 years of work, to be honest, to get to a point where a system that's designed for single types of stock really now has to deal with interoperability. CPC was never conceived to do that. So you know, we're still on the learning curve with that, to be fair.
So I guess that's what we're saying. You've had to dovetail the automatic setting from the ICC control center.
Yes. Yeah, but only only a sort of like a train routing prediction kind of thing, not as a vital safety interlocking thing. Just and that, yeah, but we'll solve that. That's a fairly standard thing for software control systems to interface together. So,
but Sam's doing himself down 2 weeks ago. The Chiltern train was running in SMA 9 in Harrow under with the CBT system on. So, and it worked. So we had a lot of issues that weekend, but the major things were that worked, which was good. Right. But it might be the honeymoon period, you're right.
Thank you. Any more questions?
I know I decided about peaceful. I just wanted to ask a question asking which I've been working on a project about adding more engineering
so that isn't in our scope to fit. I think if it goes around very correctly, gets hauled around by battery locomotive. So we put a battery locomotive on either end, which has the signal system on, and then from a signal perspective, we've done TRV middle, which then just gets moved around to do its track recording, and that's how we'll deal with that. We're not fitting that train. We are looking at procuring a new fleet of engineers vehicles. Of course, we will have to solve the multi-signal challenge on a new fleet, and we may choose to do it very differently to how we've done it with 5 systems and a big switch. That's still in its absolute infancy in TfL as a program. Very early stages. I think our engineering fleet are very much life expired really, and we'll be managing them until the point will be change them if funding the TfL and all of that. So we may end up not doing that. Because I think he's seen this in this cycle in TfL where we say we're going to change our engineers vehicles fleet and then we don't keep them running. We're now in that cycle again where we're trying to look at how we change them.
Yeah, we've got parts of the road that years old.
I think one of the biggest challenges of EVs has been what we call engineering vehicle superhighway, which is the ability to run EVs in amongst passenger trains. We wanted it when we did SMA 2. We eventually got it going at SMA 5, but still with an awful lot of operational restrictions. And that's been a real challenge. It goes back to what Sam was saying earlier about variable train lengths, uncoupling in possessions and moving around. It just adds a complexity that is a nightmare to be
Just a no-no for a signaling CPC system and the principles of it. They just don't work together.
But I've actually been working on the concept of the seven problem. That's one of the challenges that we come back on board and say round of drivers and stuff that we need to like the only question that they have is one is with the single system. But obviously understand, it's, that's what I want to.
It's sounds simple, right? If you're doing it on back train, then you can try might not do it on the turbo. To just design the interface to fit it is a huge amount of effort for a one-off train that can get around the network elsewhere. I guess I wasn't really involved in the business decisions about what was doing, but I'm guessing that was their thinking. But others in the room on the call may know more than me about why we didn't choose that train. It's just cost.
Okay, thank you. Maybe just time for one more question from the room. Sorry.
Thank you very much for the great talk. Apologies in this question. I was wrong software engineer until 2020. And then there was lots on this one. The things that we stuck out to be honest with you, there is a good sounds. I don't think there's anything else since at the time there was abuse the discussion. A lot of people talk well when the signal is complete, they'll be using sounders and shorter stopping distance and all that kind of stuff. So I was wondering if that's something that's being turned on, being brought into use, or does that have any implication for you guys? Or whether that's being
so as part of our overall adhesion management strategy, it doesn't really change what projects are doing with the signalling rollout. But I think there comes a time when CBC's on the Met line and Sanding must be kind of commissioned and working on the stuff. It's a bit of a tipping point. I think it doesn't impact us too much. I think it might be on now.
I think it's a use.
Yeah, but it only dispenses sand on the braking, as I understand it, and doesn't necessarily help you in other areas where we suffer adhesion problems. A CBC system traditionally suffers adhesion problems, both on acceleration and on braking. Sand is a braking mitigation because drivers normally defensively out a train. Signal system doesn't try and be defensive, it just drives as fast as it can, squeeze it can, hopes for the best from an adhesion point. Well, certainly this one does.
Okay, thank you. And maybe last question from Toby online. Toby, if you'd like to ask.
Hello, can you hear me?
Yep.
Great. Okay. Yeah, I was just thanks for going to say thanks. Really interesting presentation. I just would imagine that perhaps a modern digital signaling system comes with some potential obsolescence issues. And I wondered if that was the case and what management plans there are in place to sort of manage that over the many years of service that it will have.
So a similar answer to what Chris gave. We have obsolescence management. We get notified of obsolete components, software, hardware. Tend to put most of that through a maintenance support contract, and that gets dealt with in the future. The biggest what we're dealing with right now is actually software obsolescence. So a lot of the servers and firewalls, an example, are on operating systems and platforms that are no longer supported by the manufacturer, be that Microsoft or the Linux-based one, or the firewalls are now got like security warnings on them that there's vulnerabilities found, and we have to not necessarily obsolete, but we have to upgrade them from to be cyber security compliant. So we're actually dealing with more software obsolescence issues than hardware at the minute. Hardware is definitely going to be a obsolescence problem for this network because the hardware was designed. It takes so long to get the system in that the hardware was built 10 years ago and designed 15 years ago. So it's going to be obsolete before we even put it in, really. We have to make sure we have a good spares holding. We have to make sure that we have a roadmap with Thales really for next generation. So we've got the next generation of hardware on Four Lines network and the Jubilee. There's a project that's upgrading the Jubilee line with the same generation. So it's a bit of a rolling replacement program we have in TfL over the long term to kind of manage that. We have to work with our suppliers. So the project don't tend to. We try not to give obsolete care, but it's almost impossible because of the timeline. So we're just mainly managing software obsolescence.
I talked about a framework that we've got for effectively more capital work on it. We do have what we call a TSSA contract with Thales, which is all about the day-to-day support that's needed, level 2, level 3, etc. And addresses some of those obsolescence issues.
We have a very good spares holding. We have a very good second line maintenance team that do their best to repair things and bring them back to usable life, so we don't have to worry that we haven't got said component anymore or what have you. So like every major organisation, we try and get by.
I think it's also interesting. Put your shoes in the put yourself in the shoes of the supplier. I've talked to people in Thales, and they scour the market to try and find out what are their components that they're putting into their product, and when they're expiring, and then suddenly get caught out that what they thought was a steady stream of components coming through is stopping, and they have to redesign their whole product. So there are all sorts of levels of this, and we're right at the end of it.
We also have to we also manage not necessarily obsolescence types of Thales, for example, they chose to discontinue the radio product that we've got on 411. They've gone to a different platform, more cyber secure, taking advantage of more modern comms architectures. So they're now supporting pretty much a special for London and a few other metros in the world. But so we have to manage that as well with our suppliers, that some of the sort of design solutions are no longer the base product for the suppliers, and they're managing. They have to keep that capability to support them long term. That's a challenge as well.
Good. Well, thank you very much. Been really, really interesting for me. I work alongside some of the guys that work on the 411 project, and I've learned a huge amount tonight. So really appreciate you coming today, and maybe we could all thank you in the usual way. Anyone who'd like to join us for a drink, we're going to the Red Lion pub just down the road after this. Thank you very much, everyone.
Thank you.
I'll ask Alf if there's any more questions.
Thanks, Chris.
That's all right. Still on the spot.
You tend to be